go through the examination. So it's going to be an interesting session as we move on. And so we're just going to brush through some sessions, like the introductory sessions, understanding the big data, introduction to big data, and planning. So the introduction to big data. So we're talking about the structure of big data, element of data, the velocity, the volume, velocity, and variety, and the application. And I think we had some of application approach that we were taught in terms of fraud detection. So in the first part of our class, we were taught what is big data, and there are different definitions to big data, like we were told. I know very sure that Blessing would have given this example that like 30 years ago, the means of transferring data is just like a 3.5 floppy disk drive, where you just have maybe 3.5 MB drive, and that's the highest thing. Then when you have a 10 gigabyte drive, it's a very big deal for you. Talk less of having 50 gigs hard drive. Talk less of having 1 terabyte. I think then 1 terabyte almost seems impossible to a common man. So we graduated from floppy drive to CD-ROM, whereby we still have like 700 MB. Then we move to DVD that's having like say 3.5 gigs, and at every point everybody will define what big data is and give different definitions to big data. So like we just understand that in time past the word big data has been relative, but to context of the environment we are now, we have the 3 V's of big data, and those are the things big data revolve around. And sincerely, they are the 3 pillars of the big data environment. So if the 3 V's are not met, talking about the variety, the volume, and the velocity, if they are not there, well, it might not be big. It might just be, because it's possible we have a weight of data of almost say 500 gig or 1 terabyte, that it is not transactional. Maybe it's just like it's static data that is not changing, and the only thing we have there is volume, maybe the size. So I might not call that big data. So but the act of big data is in the 3 V's, when we have the volume, the velocity, and the variety, and that is the big deal. And we get that from example of like transaction data. I think I would call big data like it's a platform that collects maybe it's an atmosphere of transaction data. So anytime you have a transaction data, especially transaction data across different channels, or let me say communication across different channels, then data will be generated. So in terms of fintech, or let's say in the financial world, you see transaction data across different digital channels. So at the end of the day, what is generated is a big data, because you have the volume, data is massive, having at least, I think we've worked with data of around 400 million rows, and there's a project we're also working with, and they say, see, you should make ready of 2 terabytes of data, excluding the installation on the system. So when we talk about transactions, so any transaction data forms the bedrock of big data. Transaction might not be financial, transaction might be calls. So when we go to telco too, we see a lot of transaction going on, a lot of calls, incoming, outgoing calls, through text messages, through use of data, through different plans. So you have the variety. So as you have the message leg, you have the text, you have the voice leg, you have the data leg, and transactions are happening. So at the end of the day, you can see that this kind of data, they will satisfy the volume because they increase with time. We're talking about the velocity, and they varies. Talking about different channels. When we go to social network analysis, which I know we've touched. So when we go to example of what happens on Facebook or what happens on Twitter, you see transactions happening there. So I said something in the context of what I'm explaining. Transaction might not necessarily implies cash transaction. It's like engagement when human engage with a system to perform a specific action. So that is my definition of transaction. So when we go to Twitter or Facebook to comment, you see hundreds of comments from different users. So you see Twitter is satisfying volume, variety. When talking about variety, method of input. So some inputs might be text messages, some might be voice, and some might be images. So you see variety. So when we have this kind of environment, and we are trying to bring out insights from block of big data, then we need a big data analyst, and which could help us. Who is going to help us derive insight from anything we'll be doing. And also, I know we talk about the advantages of big data, and there are countless advantages of big data as we've learned in time past. So it enables us to understand customer behavior better. I think that's one of the big deal. So far, what generates big data is transaction, and it's being done by particular customer, or let me say by human. They will need to understand their behavior better, and that's going to give us a edge above them, and it's going to help us build a lot of products. What these guys, what Facebook and Google, Twitter, what they are enjoying is they have the big data to learn customer behavior from. So any platform that is being developed that people can easily generate data, it will be very easy to identify what is the customer's need on the platform, and those are one of the advantages of big data. It helps us understand what is the customer behavior, and with the customer behavior, those companies can easily build products according to customer behavior. So product creation is a derivative of understanding the big data generated by customers, and which helps the company to take a proactive measure to what the customer needs. So we see one of explaining this better. You're going to discover that Facebook can just come up with something, and they bring out a product. And anytime they bring out the products, we discover that, oh wow, this product is on point. When they do something, feel like wow, they had it maybe on their web page. They try to remodify the web page, and it's something more fancier. And when we see them, we discover that they look like what we wanted. So those decisions are not taken from the blues, but they've understood customer behavior, and which is done through the big data analytics. Understanding the data, the volume, the variety, the velocity, and deriving insights from them give them an edge to always build a customized product. And in terms of social media, talking about Netflix, you see the likes of recommendation, video recommendation. YouTube does that too. And all these things are understanding customer behavior, which optimize the platform and enable customers to always come back to the platform. And I think this also drive what they call stickiness. So when the customer keeps coming, and that is what every business wants. I want my customers to keep coming to my platform to buy my product, to do this, to do that with me, and that's that. So those are one of the advantages of big data. And talking about cutting down expenditure in healthcare sector. So there are a lot of ways big data is helping in reducing costs of healthcare facilities, and especially times whereby we have shortage of doctors. But when there are a lot of data to train a particular model, then we can easily know what is the prevalence of sickness in a particular community. Then necessary actions or necessary medications, necessary things are deployed to those kind of environments for quick relief of the patient. And sometimes some devices that are very expensive before, building a smart device now make them very cheap. And we can easily people can easily access healthcare facility. And one thing the big data also does is that increasing the operating margin of the retail sector. I think retail guys are the one enjoying big data amongst retail guys, though it's cut across every sector. But when you talk about the volume of transaction, it's mainly retail. Those we guys that buy things in bits, like you get recharge card, you make phone calls, you do this, you do that, you go to the shopping mall, and all retail enterprise. So it helps in increasing operating margin, so increasing profit, and also trying to minimize cost of overhead costs and some other costs that the company might incur. All right, so those are a few of advantages of big data. Also, I know we were talking about the procurement, talking about it helps in procurement of product development, manufacturing, distribution, marketing, and price management. All these things are very real, and it is interesting. With my little experience in the industry, I see all these things playing out. They are playing out big time in helping the business grow. So, which we believe that after this course, we're going to go to our various organizations to implement some of this knowledge that has been passed across to us. Okay, so and another thing is that this is a review class, so but please in case there's any question, so that I won't just be talking. So in case there's a question, I would like you can please stop me and ask questions. I'm always available. In case anything is not clear, I'm available to answer questions. So tapping into various sources of data. So we have the social data, matching data, transaction data. Yeah, yeah. I know in this course we've talked about social network analysis.
Sorry, Edward.
Yes.
This is Tunde. Since you said we can ask questions, I was wondering that since we started the class, we've been talking about data and all these things. We never even have an idea of how the exam, how the certification is, and it's usual for to always start and say this is the end to what you are working at. This is the way the exam looks and the rest of it. Or maybe it's going to be back end for this course before you tell us.
All right. Thank you, Tunde. Sincerely, yeah, yes, that is part of the package for the course, and it is also always needed for us to understand. I'm about moving to what they call the exam check. So we see, okay, before we leave the class today, I think I'm going to dedicate like 30 minutes to talk about the exam. How do we pass the exam? How I passed. So it was interesting that the exam is not so difficult, and I'm going to, at least before the end of this class, I'm going to give 30 minutes for question and answer, and I'm going to give tips on how we can pass. And like you said, sincerely, thank you for that. Though I had that in mind, but you noting it is going to help me bring it forward as fast as I can. We need to start our planning for the exam now. So when we are reading, we will read like the exam is tomorrow. So, and before the end of the class today, we are going to walk ourselves through the exam tips, and I can tell you the exam is simple, though sometimes it can be very scary, like wow, DASCA. But I can tell you in real, when you go to the exam hall, so wow, one of my guys will say it is commonsensical, DASCA. So we'll go to that. Thank you for taking note of that. Okay. um like I said earlier, there's different sources of data: the social data, machine data, transaction data. Those are the main forms of data which we can we need to know how to work around them in production. Social data, especially for fraud detection. So social data is a data that is rich in explaining fraud. Like, we believe that if Mr. A is fraudulent and Mr. B has a strong relationship with Mr. A, there's tendency that Mr. B will be fraudulent. So if Mr. B should perform a transaction or come for claim, we need to investigate that claim further to be sure Mr. B is fraudulent. Though Mr. B doesn't have a fraudulent transaction before, but because of his relationship with Mr. A that has series of fraudulent acts, there's tendency that he has been influenced, or probably there might be tendency of fraudulent transaction in Mr. B. So social data is a data that is rich in those kind of customer behavior. When I was going through this session again today, I was like, wow, so if people understand the effect of social data, many people will stay off social media, or probably they are going
Please,
to watch what they do
can
on
I
social
ask a
media.
question?
Okay, you're free.
Just referring to the analogy you use, how do
Okay.
you compare it to what the fraud management system does in banks and other e-commerce this thing? For instance, in banks, the fraud management system looks at transaction pattern and blah, 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 blah. So does it, even though I'm not sure it's comparing one customer to another customer, but does it, is it relevant to what you are saying? Is it a social data as well, or transaction data?
Okay, so in terms of the fraud analysis that's going on in e-commerce for now, it is mainly transaction data. It is mainly transaction data. So I'm just saying, if they can leverage more, if they can bring in external data like social media data, they can use that to check the customer behavior better. You know, customers are very flexible on social media. On social media, people easily tell who they are. Like, people, customer behavior can easily be seen on social media. So we discovered that the social data can help optimize, or let's say increase the efficiency of, let's say for instance, a fraud model. When you combine both the social data and the transaction data together, it can easily help infer that, especially based on relationship. That is what social data will bring. Relationship, which is not available on the regular fraud detection data in e-commerce environment like the bank and the like. So they've not, most companies have not integrated social media data to their fraud detection model. So but it's something that, if added, is going to help the business in a lot of ways. It has been tested and approved that social data increase the efficiency of fraud detection models. Okay, I hope I've answered the question. Okay,
Yes. Thank you.
you're welcome. So so that is that, and I think we've had some bit of what the big data is, and the structure of big data, and the types of big data. We have internal sources, yeah, like when you have transaction data, they are internal sources, and when you talk about social media data or probably third-party data, they are external sources. So it is always needed when you bring in the two data sources together and run analysis on them to build a model. It makes the model more rich, robust, and very flexible. So so we have external sources that we need to always keep in mind to try as much as possible to get to augment the current data we are having. So that's that, and we also have the three forms of data, talking about the structured data and the unstructured data. Transaction data are very structured. Transactions data are very structured. When we talk about social media, they are unstructured. So that's why many people stay off social media, because it's mostly unstructured. When you talk about the sentiment analysis and a lot of NLP and algorithms on text analysis, so it is highly unstructured. So that's why most scientists we are very used to making use of structured data alone. But if we can build data in a strong, we can, I'm very sure there are ways we can convert unstructured data to structured data. For instance, now if I have if I'm having a case study of, say I'm working on, say, 1,000 customers, and I want to go and see, and I have handy their transaction data. I know what they do, and but I want to know their behaviors. I want to know their social behaviors. So what I can do is that I go to their social media handle and I try to scrape all their comments. What have they been saying all this while for the past 1 year? So when I scrape all their comments with dates, timestamp, I now check. I can decide to check. Okay, I want to classify how many negative words do this person speak per day, and how many positive words did this person speaks per day. So I can try to understand what is the tone of the customer. So with that, now I can now have my primary key, like the customer ID, or let's say the customer username or user ID, and I have another column, say positive word count, negative word count, and I also have another column called sentiment value. Um, is the comments of the customer positive or negative? So by the time I create those kind of table from the comments, it's going to now look like a structured data, which I can now merge with the now regular transaction table to build models. So we have structured, and I've given an example of unstructured data and how we can extract meaningful insights from unstructured data, whereby we can also match structured data with unstructured data in a way that helps us build a model effectively. And we have the semi-structured. So all these guys, I'm sorry, I use the word guys for some things. So all these components are what makes up the word big data. So and that is that. So one thing we should keep in mind as we go in this class is, please let us take time to go through our knowledge check. One of the tips my boss, my oga told me, he said, Edward, make sure all the knowledge check in this textbook, make sure you familiarize yourself with them. Make sure you at least attempt everything, get answers to them. Those are part of the exam tips, and which helped me, and it really helped. It really helped. So let's keep that in mind. Okay, so so we talked about the element of big data: the volume, the velocity, and the variety. So and we know companies that generate those kind of transactions. Like the example we are giving for velocity, he said eBay analyzes 5 million transactions per day in real time. Just imagine 5 million transactions per day. So it's a continuous process, and they keep the analysis working. So that's the word of big data that we find ourselves. And for in terms of our volume, we said Google processes 220 petabytes per day. Can you imagine? 20 petabytes per day. That's huge. So it's highly voluminous, highly voluminous. And I was saying something about volume of big data. Now we are talking about 20 petabytes per day. And I remember I did a course when I was doing my AWS course. There are some level of data that you don't move with hard drive. You move with a drive that is as long as a trailer, like a container. So the hard drive, is as long as a standard container. So they use it to move big data. For instance, now if Google wants to move their data from, let's say, one region to another, they use those kind of devices to move heavy data. So let's imagine if by year 2020 they are using at least they are using as big as a container, as they are used as a device for moving data. What of in the next 20 years? Can we imagine what means will be what's going to be means of transporting data? I don't know. I can't imagine that. I can't imagine that. Maybe there will be a big fiber optic cable that will move those data, because those kind of data can't be moved via the internet. So there needs to be a big tunnel where they need to channel those data, like you are channeling crude oil from one state to another. So they need to do a data channeling tool to channel data from one region to another. So that's what I have at the top of my head. So we are just saying, if we have this kind of volume now, like a container, a standard container has an hard drive, what are we going to have in the next 20 years? Or what are we going to have in the next 10 years? So it's going to be massive. So and that is the world we are training ourselves to be, to manage. So if anybody is not doing big data, that person is not going to be relevant in the next couple of years. Okay, and I love another thing, the application of big data. See, talking about to better social influencers marketing, more accurate business insight. I think the business insight is what we do most of the time. But talking about better social influencers in marketing, I think that's what this guy uses. When you see all these telcos, all these banks, they say, okay, I want Whiskey to come and sing for me. I want to sign Whiskey, want to sign this guy. The reason they do that is because they know their social media influencers. 1 minute. So because they understand that, okay, all these guys, they are social media influencers and they can drive their business. So those are one of the advantage of big data. More accurate business insight, segmentation, very interesting in terms of segmentation. We can go all these topic, assuming we want to go deep. It should have been a separate topic to understand what is segmentation analysis. So I know, okay, though I still understand that we are still going to do some practicals with her. We are going to do some cluster analysis where we are going to understand how do we do segmentation analysis. So that will also be interesting. So identifying sales and marketing opportunities, automated decision for real-time processes, detection of fraud, amidst others. So, so that's that about our application, and we have areas of application and transport, education, amidst others, government, healthcare. So, and in terms of skills required as a big data analyst, so big data analysis require, say, understanding Hadoop, because there's no way you talk about big data without talking about the big data framework, and that is the Hadoop HDFS, Hadoop Distributed File System. So when I was taking maybe the second course, I see HDFS like a Windows operating system. It's like a Windows. So if we're, I think maybe basic engineering, we understand what they call the NTFS, and that is what Windows operating system makes use of. But the Hadoop is you talking about a distributed file system in a way that things can be splitted and reaggregated. So those are few things. Understanding natural language processing, statistical analysis, and understanding predictive modeling. So that's that on around phase one of understanding big data. So I'm very sure maybe tomorrow we'll be going through the practical section. But today we are still brushing through the theoretical part that we've learned and the business application of big data. So business application. So one of the business application of big data is what they call social network analysis, which I enjoy. When I mean I enjoy social network, when when I had understanding from DASCA how social network analysis can be interesting, then I value it. Though I've done some network analysis before, but understanding the impact of social network analysis, that makes it interesting for me, and understanding how it can be applicable in the industry. And the analogy that is given in this book is that you have a customer. This customer, by value, by value of transaction or by volume of transaction, the customer only does say 3 transactions per month. The guy is not an heavy pusher, but when you check the network of this guy, you discover that this same person has in his network guys that calls him. Though this guy does not recharge, but he has a lot of guys that calls him. I'm checking the transaction of guys of his incoming and outgoing call. Discover that those guys are heavy pushers, that they recharge their phone a lot. So if you then want to maybe say because of this guy for the past 3 months he has not recharged his account, let's sanction him and send him a message, or let's say feel like okay, let's put him in a low band bucket. There's another part of analysis, they call them high value customer. So when because of the guy is not transacting much and you feel like okay, well, let's make this guy is not fit to be a high value customer. Whereas I'm checking the network of people he relates with, they are high value guys. So that implies that customer, though he's not transacting a lot, he's not recharging his phone, but because of his incoming calls, his friends are high value. That is going to, so he's going to inherit the trait of an high value customer. So that's one interesting thing about social network analysis, which I found interesting. So I remember there was a time we were asked in our team to build a model called high value detection model. So, though we are unable to add this to it because it is not a telco environment. It's like a financial institution. It's a bank. It's for a bank. So this might not be applicable, but I'm just saying that it's the application is very real and interesting. So seeing the network of a particular person and seeing the effects on the revenue, so that's going to help us value every customer based on the network of other customers or friends they connect to. So, and using social network data, it can be used for what they call the business intelligence, marketing and product design and development. So please, all these things, let's keep them in mind. Keeping in mind the uses of um, all this big data methodology. So understanding the business intelligence, the marketing, and the product design. Then when we get to the exam, the question we can have options and say, okay, what are the use of social network data analysis? So, and one thing about DASCA is that they don't take anything outside the context. Maybe the exam I did then, though I see some guys saying, oh, there are some things that are not in the textbook, but for my own exam, I feel they are like 95% on track. So they can ask questions like, what are the use of social network data? And they list these three, and they ask, or they list some other options, and they add one of these and just say, okay, pick one, which is one of the use of social network data, and the ability to identify them. Just say, okay, I know social network data can be used for business intelligence, marketing, or product design, and that's going to help us to at least pass that question. So those are part of the exam tips that we need to carry along as we move into this class. So so that is that. So moving forward, the social network can be used for also marketing, product design, and I know these are things we must have understood in time past. Understanding product design. So product that is being designed by Google, it's as a result of social network, understanding what each network requires.
If I can't see your screen, I don't know if you are sharing anything on the screen, but I can't see.
Wow. Okay, I'm not sharing screen. Sorry. So I'm not sharing screen. Okay. So I'm working with our textbook. So do we have our textbook close to us?
Which of the books?
Book 1.
Okay.
Book 1. So so I'm just trying to do a scan of what we've done. So currently I'm on page 26. So please, to other team member, please, so if we've gone through the book, we can easily relate to what I'm saying, and this is just to sync to make the knowledge so that we can understand better. So that's why we're having this session. So we can find everything I'm saying inside our book. So next time we are going through them, so that when we see them, we understand. Okay, Edward gave an example on this. Okay, so product design, that's use of social network analysis, and another thing which I said earlier is the financial fraud and big data. So fraud has been a major issue, especially in the digital world. So the digital world, as we have big data now, the digital world is more fraudulent now, more fraudulent, and one fraud can sink the entire company, because there can be a fraudulent transactions that can amount to billions of dollars. So talking about fraud, it is another new area that researches are being done, and they want to find a way to reduce fraud and detect fraudulent transactions, especially now that we are having digital transactions. You buy everything online, and how do they verify if you are the real owner of the card? What are the algorithms they need to put in place? How do they track? How do they do? That's why we see something called like the two-factor authentication. There are also fraud detection measures to reduce level of fraud, but there's a need to also reduce fraud. So there's fraud analytics specialist, and it's also one of the advantages of big data. It's one of an interesting project to work on, and it's a project that is sellable if you can try to explore. Okay, I want to build a fraud detection algorithm or a fraud detection model. It's going to be something that's going to sell, because there's high level of fraudulent transactions. Though many companies might not disclose the rate of fraud attack on their business, but it is really happening. And I think I've had a discussion this week, and one of the discussions is around fraud. How do we reduce fraud risk in the business? So, and we have financial fraud and big data. So, the credit card fraud, exchange or return policy. So, if you go through this exchange and return policy, a person can claim he has returned the product and he has not returned, and there can be a lot of things and fraudulent transactions to say, okay, uh, the product you gave me is not good, and whereas it's just and the customer did not return the product, and it has been refunded. And there are different fraudulent actions. And we also have personal information where people impersonation. I think that's very high. Impersonation is very high, whereby they use other people's credentials to log in. How do we detect that? So I remembered also there are a lot of ways impersonations. So I remembered, okay, when I took a course on Coursera some years back, and one of there's if you want to write for a test, if you want to write test, what you do is that you type in some set of characters. So that is what's going to be used to check if you are impersonating or not. I think maybe that's just a low level check, but their level of impersonation fraud, and people and businesses are finding a way to solve it. So big data is a way around it to build a fraud detection, a personal information fraud detection model. So, and most of this needs to be in real time, because all these transactions are in real time. So it's a lot of work. It's a lot of work, but it's always interesting in real time. So also let's keep in mind that anytime we are reading our textbook, uh, okay, maybe another exam tip that do help me is that there's something at every corner, which I told us earlier, the exam check. I make use of the exam check a lot. I consciously work with the exam check and say, okay, for instance, now in page 30, they said in your certification exam, you'll be required to demonstrate the understanding of application of big data for fraud. So one thing is that understanding that, just keep it in mind that, wow, so I need to understand this, I need to understand the application. So when we put mind to all those little things, by the time we are finally preparing for our exam, would have gotten enough knowledge in our archive to work with. So we have fraud for card fraud, and we have fraud for insurance, and the social network analysis is good for fraud in insurance. It's a model that works for fraud in insurance, like the example I made earlier, saying that when we have social network analysis, if a customer A is took a fraudulent had a fraudulent claim, and customer B is a friend for customer A, what's the likelihood that customer B is requesting for a fraudulent claim? So things like that, especially in social network analysis. So in production, we can be thinking of how can I apply this to my business. One thing I believe and I enjoy is that everything we are learning, as much as we are planning for the exam, we should also be thinking, how do we implement this in our business? How do we build models? And data science, big data is about product, is about solution. That's where the real value is. And please let's keep at the back of our mind how we can build solutions to help the business, the community, the environment, based on the knowledge we are having. So we should also keep in mind the step-by-step method for social network. The like page 32, where we have following is the step-by-step SNA method for detecting fraud. So let's keep those stuff to in mind. Talking about extracting data from different sources, the analytics, and make use of big data technology, text mining, sentiment analysis, content recognition. Yes, content recognition. I think that is it's a technology that really helps. I recall that there was a day we are at the office, and we just had a scam alert. You are welcome, Titilayo.
Thank you very much. Sorry for coming late. I just got back home from work.
Yeah. Sorry. So we are just trying to do a brush up on what we've been taught so far on module 1.
Okay.
Okay. So you've not missed a lot. So everything we said is just a brush up on what we've been done, so that we can have a grounded knowledge. So that's fine. Okay. So I was saying something about there was a fraud alert we had in our place of work. Okay, in one of our client sites, and what how they detected the fraud was due to the content of the message. So it was an impersonation fraud, and the content of the message also flagged gave a red flag for fraud. So most of the time, if we can do content recognition, it's a good technology for identifying fraud. There's to every one of us, there's a particular way we write things. So if somebody wants to impersonate me, the content of the message will be different from what I used to do. So these are methodologies that help in this detecting fraud. We'll talk about from the book. They talked about text mining. This is page 32 of book 1. Text mining, sentiment analysis, context categorization, social network analysis. I said can be included into fraud detection and predictive mechanism. So those are things we need to keep in mind. What are the steps we keep in mind? So all these things, to me, one of the things I will tell us is don't let us cram this. We should not cram. Like, okay, yeah, I need to understand everything. No, just let's. I think we are business guys, and we are already in the business, so we should just always try to have a mental picture of all these things. I don't cram, and because if I should tell us that, make sure you keep note of everything, that's a lie. It's not going to come out like that. So what we are going to be tested against is our knowledge base and how we keep all these things in mind. And if we can just understand just the basic principle, when we get to the exam, we can logically think through to choose the best answer out of every question. So that is one thing I will also give us as a takeaway, especially for exam tips. We should keep in mind, we should just understand that okay, these are basic method, and when we sit down closely to all these methods, we discover that they are logically okay. Like we can attach logic to it. Like the first one saying, okay, the data, both structured and unstructured data from various sources. So commonsensically, that is the first thing any data scientist will do. You get your data. And the second thing is that the analytics team uses information from various sources, scores and risks of fraud and ranks the likelihood. So so there's a technical to some of us that had some technical analytics skill. So we can technically think that through and say, okay, well, this is also technical. So it's just like ranking. Okay, what's the probability that this transaction, after we get the data, what's the probability that, or the likelihood that this transaction is a fraudulent transaction, and we scale it maybe in the scale of 0 to 1 or a classification of 0 and 1. So after doing that, now talk about the methodology to technologies to use, and we talk about now deploying. They now say depending on the score of the particular network, an alert is generated. So having built the model, we now push to production depending on the score. So if the score threshold is like 40%, and if it's above 40% likelihood, then you should trigger fraudulent alerts. But the likelihood is still 30%, and the fraudulent alert is not triggered. But as soon as it strikes the threshold or exceeds the limit, the alert is triggered to say, okay, this transaction is fraudulent and we need to flag it off. And talk about the investigation. Investigate, okay, how true, so that we won't mislabel a transaction as fraudulent alert. Because if a true transaction is labeled as fraudulent alert, it might affect the business. When I'm trying to log in and the business is telling me, Edward, see, we discovered that your IP is one of the listed fraudulent IP. I'm like, wow, what's happening? This my account, my username and password is correct. What's happening? And I might feel like, well, let me check on that platform. So there's a need for investigation. So the fraudulent alert to just flag it out, guy, please investigate further on this. So that is that, and we see some also other option investigation, and finally issue of fraud that are identified. So it's an interesting solution, like fraud. So I wish I do something very soon on fraud detection, and push something to production around it. Okay, predictive analytics. So also we have our predictive analytics. As we understand, it's just a way to predict what's going to happen, and that's that. As simple as that. So just predictive analytics, and we can have, is it going to be an upward trend or a lower trend, a downward trend? So we just want to understand what's going to happen. How is my customer going to behave this month compared to last month, or how is my customer going to behave next month? So we can have a lot of predictive analytics, and a lot of them. We have a lot of them, which before the end of this course, we are going to see a lot of predictive analysis. We're going to see classification model. We are going to see regression models, neural network, a lot, some nice stuff on predictive analysis using R. Okay, so another thing we keep in mind, we just need to keep in mind is the social customer relationship management. So this tool around the social network analysis, linking the customer behavior with what the customer is doing, and especially the customer feel. Also, it's also helping in understanding what is the customer feel about the business. So most of the time when you make transaction, or maybe I see this with one of my bank, I say, okay, how do you feel with this transaction? They put a scale of red to green, and they feel like, okay, what is your feel? And you pick green, and I think that's just is a pool, but that might not be the real picture. So let's go online to see what are people saying. I see some banks, I see some guys, they will put on their WhatsApp status and say, bank X is a scam, they've been deducting my money unnecessarily. So those are part of social customer relationship management methodology for big data, whereby we can understand customer behavior and understand customer feelings, sentiment feeling, and which actions can be taken aside just using school and the like. So that's that. We're on page 34. Use of big data in retail industry. Yes, I think we've talked about some retail business, and also I like this method, this technology, the use of radio frequency identification data in retail. So now I want to give a question. Like, I think I've been talking. I think I'm just dishing word as if I'm presenting, and this should be a class, right? This should be a class. So yeah, one last question that's around. Um, what are the uses of radio frequency identification (RFID)? Can anybody bail us out? The use of RFID in the retail world. I'm on page 35. So who is going to build the class house, so that it's not going to be a one-sided talk all this while. So at least we can we can we can all be engaged. Okay, I'm here. I'm waiting for. So but we can look into our books. So this is not a classwork. Oh. We can pick our material, because I'm assuming that we are close to our material, so we can look into our material and see what are the uses of RFID in the retail world. The reason I'm asking is that because it's a technology that I don't, maybe because of my current domain work, the current sector I'm currently working. I've never seen the use as such, but I feel it's a great technology for the retail world, and it's interesting. These are things that caught my attention when I was doing this course. So, and I would like us to just discuss it in the retail world. What are the advantages? So we have a lot of advantages. So okay, I see there is nobody to build the class out. So on that note, I will build the class out. Okay. So I know it's possible we are stressed up and we are just getting home, and like, guy, please let me rest. So I understand some of us need to rest, like um Titilayo that joined a bit later and saying, okay, I'm just getting back from work, so I know you might be stressed. So okay. So in the exam, we might see questions that might ask us, what are the, just give a list. The exam is it's an objective exam, so might just be asked to just seek which uh, which are the example of RFID, talking about asset management, production tracking, inventory control, asset management to understand, okay, now what about asset management? We see, especially when in our place of work, we see on our chairs, we see stickers on it, especially when you go to banks, you see on stickers, they say, okay, if it is say bank ABC, say bank ABC slash chair slash 001. So that just giving the chair an identity to say, okay, if the inventory guys want to take stuff, they understand that, okay, we have this chair number, this in this office and the likes. So instead of using all those stickers, we can use an RFID tag that will be digital. You can get to understand the location of that asset, so nothing just gets missing outside your radar, because you are keeping track of what's happening. And also talking about production tracking. So on this production tracking, you put on each pallet, you put all this RFID to track what's happening. Where is my container moving from? Where is it going to? And you use it to track, okay, on this pallet, how many pieces, how many cartons of products do I have on it? You have information stored on your RFID tag. So it's just like a mini chip that stores information. And we have some that are reusable and some are not reusable. So, and you see some that are very durable, regardless of heat. They can stay in the sun, they stay in the rain, and they are highly durable. They get data for you. I see that as a technology that should be used, especially in the production industry. So guys that will do a lot of productions, carry pallets, this and that, all these movements. So inventory controls, controlling inventory, shipping and receiving. So you know, if I'm shipping a product and I have my RFID tag, you can use it to ship and be sure when the product gets to the location, use it to track, okay, the products at the location. So it can be very interesting. So that's that, and we have the regulatory to regulate compliance. So we have lots. So also like I said earlier, we should keep in mind in our certification we'll be required to demonstrate an understanding on application of big data in retail industry. So what are the application of big data in retail industry? So we should keep in mind all those stuff, and the use of RFID is one of the application that is well pronounced. And talking about the asset management, production tracking, inventory control, the shipping, regulatory compliance, we need to keep all this in mind as it is requested from us by our exam bodies, DASCA. Okay, okay, and we are moving very fast, and I think, okay, technologies section 3, interesting. One thing is I enjoy DASCA and I enjoy the word of big data, because that before I start for my DASCA exam, or before I did DASCA certification, I've been reading about Hadoop for at least 2 years before my exam, at least or let's say at most 2 years before my exam, like let's say at least 1 year before my exam. And all the materials I've been reading about Hadoop, they are buzzwords. They are like buzzwords. But coming to DASCA, it gave us a simplified way of understanding the big data framework, especially understanding the technology of handling big data, which is the Hadoop framework. This is what they call the distributed and parallel computing for big data. So I'm very sure in time past we've been taking through what we call the distributed computing and parallel computing. So distributed is let me say something about distributed. Distributed is just like when your processors or let me say when the nodes are not using the same memory, then they are distributed. But when they are using same memory, then it is what we call parallel computing. So how do I know this? So that's just the mental picture I pick in my head. Now when I talk about distributed, they don't share memory, but in parallel, they share memory. So like when you have five processor sharing different memory RAM, then they can't be in parallel. They call it on the Hadoop framework, we call it the distributed framework. But if you have like 5 different processors sharing one memory, then we call it a parallel system. So one thing about Hadoop is that it can work on both the distributed system and the parallel system. And the efficiency, what this does is that it makes the work very fast, very fast, very fast, very fast. Like I think it's one of the best framework that's that is working now, the distributed framework, and it makes query runs very fast, and especially when it is big data. So if the data is not big enough, you might not see the beauty of the distributed framework or the parallel computing. But when we have the big data, when we are querying something like say 1 million or say like 1 billion rows, then we understand the effects. When I was working, I remember there was a project we worked on. There's a project we worked on, and one of our codes, I was just trying to aggregate to, and the result of that code is just like say a 9 digit, or let's say a 9 value result, and the result ran for almost I think 16 hours because I was running it on a distributed on a normal relational database. So assuming the same process, assuming it is being run on an HDFS environment, regardless of the volume of data, instead of running for that 16 hours, it might just be 1 hour. It might just be 1 hour because I know the data is heavy. It might just be 1 hour. So those are some of the advantages of our big data framework. So we should keep in mind understanding the distributed framework and the distributed computing and the parallel system. So and one thing is that in spite of the technology, there's another problem at hand, and that is called the latency. So these are okay. So the latency is like the time it takes for data to move from node A to node B. It's something that is a problem that is also addressed. I'm coming. So it's something that is also addressed. The latency. What is the time? What time does it take for data to move from node A to node B? So and it's also something that is also taken care of. I know there are different methodologies. So which MapReduce is working on. But there are other methodology behind MapReduce that has taken care of the latency issue. We will understand this better in further classes. So I know I want to um, low down my tension. Let's say I want to reduce my pace to explain to re-emphasize the Hadoop technology, understanding the master node and what we call the data node. So like the master node, well, I know part of master node and data node. So the master node is like the guy in control. So the guy in control is just like the manager, like he's the manager of the company. He doesn't, what the only thing he does is he knows the capacity of everybody. He knows the capacity of the team member. I just say, okay, when the management tells the manager, see, Mr. Hay, please help us do this job. He knows the capacity of his team member. He distributes those work accordingly to the capacity available by each member, and especially the availability of each team member. So having known that, when all of them finishes, when all the data nodes, or let's say when all the team member finishes working, they send back the result. It does the collation and presents it back to the management. So data node is, the name node is like the guy at the central controlling every other system in terms of system requirements, job scheduling, and a lot of processes. So the name node is in control, and the data node are just slave that gets the work done. So they are guys that they are just on standby to say anytime a work is ready, please let me know. And they are communicating and say, okay, are you ready, guys? Are you available? Fine. Okay, are you available? Fine. So they are communicating per second to understand, I'm available, I'm available, I'm available. So before a job is sent, it sends a trigger to them. Guy, are you available? It's okay. See, I'm not available. It distributes the job to other nodes. Another thing it does is that it does the work of replicating data points. So that is one of the resilience ability of about Hadoop HDFS. When data cannot just get missing, so it is the guy in front, the master guy, that does the work, that makes sure those data are being replicated at least 3 times, and that is on 3 different nodes, so that if one node fail, data is available on another node and the other node picks it up and they get the job done, things like that. So understanding the parallel computing technology, talking about clusters or grids. So what we call clusters, is that it's when we have several servers connected to form a network. So when you have a grid, is like several clusters connected. So a cluster equipped with the same type of commodity hardware is called homogeneous cluster, and a cluster equipped with combination of different hardware is called heterogeneous cluster. So let's keep that in mind. And another thing we should keep in mind is, which I think I saw during the exam, is understanding the massive parallel processing, the MPP. That's part of the computing technology, and also the HPC, the high performance computing. So it's an in-memory technology that is used to increase the speed of floating point processing. So when you have a lot of in-memory application, it is best worked on the high performance computing system. So that is that. Also, keeping in mind also, in our examination said we'll be required to demonstrate our understanding of the processes distributed, parallel computing, and other applications in big data. So I think that the exam check is valid, because I can recall that I saw something like that around the parallel computing techniques. Okay, so any question? We have like say 20 more minutes to go before we go to the question and answer time, and the exam tips fully. So, but any question before we proceed?
Hi, Edward. This is TT.
Hi, Titi Lion.
Okay.
Okay.
I just want to
I just
find
want to
out, do
find
you
out,
have
do you have
past
past
questions and
questions and
answers that we
answers
can
that
use
we
to
can use to
practice?
practice? Okay. So that's the challenge about DASCA. No, I don't have one. And the best question I can suggest for us is we'll walk through all the knowledge check questions. Those are the best guide that can help. So if we can answer all the knowledge check questions, I think they will cover 40% of the knowledge required. The questions might not come out word for word, but it's going to come out, at least it's going to help our knowledge base by 40%. So two things that will help: the exam check, going through all the exam check and trying to understand what the exam says, what the exam check says the exam will require, and the knowledge check questions. Those are, even if you might not be able to read the material, book 1 and book 2 from cover to cover, but try to attempt all the exam check from cover to cover. So there is no question. I can tell you, if you get any question now, all those questions will be discouraging. I can see some questions, but the best question is the exam check questions, and that was what I used. Hope I've answered the question.
And yes, but one more. I thank you. You've answered, but just one more thing. Are we going to also try the knowledge question out in the class as a team, or we have to do that individually?
Okay, yes, we can do that individually, but we can also do that as a team. So okay, so maybe what we are going to do for tomorrow is that maybe today we can go through, maybe tomorrow part of our sessions after the practical class we go through the knowledge check. So you can do it individually, to maybe at the end of every class make sure you just go through the knowledge check at the end of every class. So that, and one thing I do is that I tick it, and at least I write the answer in front of it. uh, if you check my material, I've noted all the questions. I can say if the knowledge check is having two questions, when I go back to the question, to the book, and I see the answer, I'll just write question 1, this is the answer, question 2, this is the answer. So anytime I'm reading, I make sure those are the things I keep my mind to. So we can do it as a class, but it is good whereby we all try it out individually first before we come to class to now do correction. So if you now have reservations, or probably we are doubting some questions, feel like okay, maybe I'm not getting this, can I get a better answer, then we throw it to the class, we'll see what other team member has done, and we answer that, and that's going to really help the class. Okay, yeah. So thank you for the question. I think it's also a question that every one of us is going to keep to mind too. Okay, and we keep in mind another thing, and those are the primary component of Hadoop, which is the HDFS, the Hadoop engine, the MapReduce engine, and the Yarn. That is yet another resource negotiator. So these are the four basic components of Hadoop. These are what makes a working Hadoop system, So when you install, assuming okay, on the engineering class, there's a need for us to understand the installation. So when we install, okay, on our lab work now, we can see that anytime we initiate the Hadoop environment, and we try to see the running processes, we see that when all those name nodes, the data nodes are working, we also discover that the map reuse environment is also working. All the components are running. So to tell us that those are the basic components that is needed to run an Hadoop framework. Please, 5-10 seconds. I'm coming. Okay, sorry for the break. Okay, so it's good for us to understand the Hadoop, the component of the Hadoop system. At least I'm very sure during my time I remember at least a question came out on MapReduce. A question came out on MapReduce. So we need to understand the MapReduce framework. How does MapReduce work, and how does the system works? So we have a picture, figure 3, displaying the process of job tracking in MapReduce. So this is what happens. So when a job is done, when you send a particular command, let's say you are doing, say, select star from a particular table, what it does is that same select star, that same function is distributed across all servers. Because how Hadoop works, we have data replicated on each server, and different chunk of the data will be worked on independently. So different chunk of the data will work on independently. So I wish we are in class and I can explain some things, but at least as much as I can, I will try. So when the data set is distributed independently, replica is distributed across different data nodes. After distribution, when an action is, when there is a call to action, it goes across all the data nodes, perform the action. When they get the result, they return the result back to the Hadoop software to release the output. Please, to understand this better, please let us work closely with our online resources. I think the resources we have on our DASCA school. So I think some videos, when we see those videos, they explain, they broke this down into a layman word. I think sometimes I might be technical. So, but I'm trying to know. I'm trying not to be too technical, but I'm recommending that we visit the DASCA school so that we can have a grounded understanding of what is really happening here. So, assuming I have a whiteboard that I can demonstrate with, that would have been better for me. But because I don't have one, so that's something about MapReduce. It 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 does what we call mapping and what we call the reducing. So it maps it to different data node. After the different data node does it in parallel using the distributed framework. Once they are all done, they submit it. They submit the result, and the result is sent back to the system to display to the user that initiated the query. So map reduce is just combination of the mapping and the reducing. So mapping is just separating, dividing the task into different chunks and allowing, maybe you're having 3 guys and say, okay, these 3 guys or 3 FT guys help me carry this load, and they said, okay, no problem, I want to carry a bag of rice, let's carry it in. I want to carry, maybe they want to carry a bag of rice. Okay, let's say you want to carry 3 bags of rice from location A to location B. They will then say, okay, help us carry these 3 bags of rice, and because they are already 3, they just say, okay, you carry one, and they carry the 3, they get to the location and drop it. But if just one guy, the guy will go 3 times, it's going to take a lot of time. So the mapping is assigning the job to 3 guys. The reducing is that they are doing, so when they are done, they converge in one location to say we are done. So that is like the closest explanation I think I can give for now. So so we need to keep in mind those 3 components of Hadoop system, the HDFS, the map reduce, and the yet another resource negotiator. So and also we have the cloud computing and big data. Cloud computing. So cloud computing is another aspect of modern day technology that is helping the big data framework, and it's very easy to work on. Installing Hadoop system, installing Hadoop software on premise, it's a bit hard, very difficult to run. When I want to install Hadoop on premise, it's like a lot of configuration, a lot of setting up. But when you want to install Hadoop in the cloud, just provision your instances and do some configurations and you're done. Before now, I was thinking, oh, installing, okay, yes. Before I've attempted installing Hadoop on premise, and that's on my system, and it's a lot of work. And I remember one of my colleagues that successfully installed Hadoop then. It took him, I think he was successful after 10 trials of installing Hadoop on his local machine. And I think I attempted it once and I was unable to get through, so I just abandoned. But when I attempted installing on the cloud, I discovered that it was easier than I think. So because on the cloud you work with Linux environment and some files are readily available, just to configure your name node, data node, and when you start up your instance, your Hadoop and installer is working. So it's easier when we work about on the cloud. So that's why we need to keep note that it's easier for us to work on the cloud when we are dealing with big data. So that's why we're talking about cloud computing and big data. So and cloud computing is a method of providing a set of shared computing resources. So let me relax our nerves a bit. Before now, anytime I hear about cloud, like people like cloud, I'm like, what is cloud? People just, it's a buzzword like cloud, and I was like, I study statistics and I don't know too much about cloud, but I see my computer engineering students, they talk about cloud, and I feel like, what is cloud? And they say cloud, you store it in the cloud, and when you want to see the symbol, maybe on Google or anything, they show cloud symbol. I was like, is it somewhere in the space? And that was my thinking, that but cloud is a physical environment. It's just like it's not in the cloud. It's like a physical environment, like a normal physical data center, just with the ability to share those resources to different users. So we are just communicating to a physical system somewhere that is having the capacity to share resources to different users at different time. So it's our ability to share computer instances and storage per time, and that's what we call cloud system. I know we know. So one of the features of cloud is that it is highly scalable and elasticity, scalable, that it can grow. Elasticity, he said, you can pay as you go. And another thing I like about cloud is maybe sometimes, maybe yesterday, day before yesterday, I was working on a project on the cloud, and I discovered that the instance after installation, cloud is interesting and it's a good to go guy. Just imagine if you should install on your system, you install, let's say, Python on your system, and you are running the process, and you discover that my system is slow. So if your system is slow, you need to get another system and reinstall everything you've done. But when you are working on the cloud, you don't need to. When you want to scale, your scaling will not, the scaling of your system processor or RAM would not affect your installation in one bit. All you just need to do is stop your instance and tell your instance, I want to change my instance from maybe 8 core to 16 core, and on the fly you discover that your system capacity has increased. So highly scalable, and the scaling affects nothing, especially installation. It doesn't affect your files, and you can increase your size anytime. And elastics, you pay as you go. If you feel okay, I'm not working, you shut down your system, and anytime you're ready, you pull up another instance. And that's one thing about cloud. And we have different kind of cloud. We have the public cloud, like the AWS, Google, Oracle has their own, Alibaba has their own. I think Ocean, there's one say Ocean, Digital Ocean, yeah, Digital Ocean. So we have some cloud services whereby you can easily provision of your 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 public cloud, and we have private cloud. So private cloud is like a data center that a company has, and let's call it, like, for instance, let's say Access Bank now, they have their data center maybe somewhere. So that data center is like their own private cloud, which any of their team member can subscribe to. So private cloud is always a closed environment. So that they will always want to, so it's going to be internal, and it's going to be a closed domain, whereby the domain is not open, it's not a public domain. So that's what we call a private cloud. And also we have cloud deliveries. We have the infrastructure as a service, and that's your physical instances. Platform as a service, we have example as Windows, Azure, Google App Engine, and many things. And we have like software as a service. I think one thing I enjoy most about cloud is, another thing is the software as a service. So the software as a service is that when you want to install Microsoft Server on the cloud, you don't need to bring your own hard copy. You just click install Microsoft Server. In 5 minutes, your Microsoft Server is installed, provisioned on the cloud, fine, working fine, and in 5 minutes, you finish your installation and configuration in the cloud. So software as a service is very easy when you talk about cloud. Very, very easy, and that's one of the advantages of cloud. You can easily provision your software and on the fly, and if you have your own custom software, you can easily install them, and you are good to go. You are good to go. So and so we have cloud for big data, we have it in the infrastructure as a service, the public cloud, the platform as a service, and we have software as a service. So we have different kind of cloud services. And an example of our cloud providers are like the Amazon, Google, Windows, Azure, among many other guys. But these guys are the top guys. I think they are good guys. They are good to go guys. Good to go guys. So and I will advise us that maybe after DASCA we can try to take a course on cloud so we understand how to set up or maybe cloud infrastructure either on Amazon, Google, or any of these platforms so we can understand how to do some cloud stuff. But sincerely, cloud infrastructure is always interesting, and we see how we can do a lot of things on the cloud and lots of things, lots. So that is that, and so that is that for now. So finally, we can read up issues with using cloud, and that is data security. So we have the data security issues. So that's why there are data policies that some data cannot go to the cloud. I know many companies will not take their data to cloud. So I had Azure, Microsoft already has a data center in Nigeria whereby you can provision your environment in Nigeria. So they're already building a data center for Nigeria whereby you still put your resources on their infrastructure, and it's going to be a good to go thing. So data security, and like I said, we should understand the policies around data security, data movement from one region to another, where should we provision our data, and that. So performance, the compliance, the legal issue around cloud issue, the cost. So we need to understand the cost of data in the cloud. What's going to be the cost? So the last time when you want to use at least a I think maybe 4-core system, 4-core CPU on Amazon, it costs like 4-core CPU on Amazon. It costs like say $1 per 3 hours. So and that's just like $8 per day. So it can be as cheap as that. So something you can easily use. And if you are just running some little processes, you can just budget for, like, if you know your process is not going to exceed more than 1 hour, then you are just spending $1 and you'll be using a very efficient system. So that is that. Uh, please let us go through our knowledge check. We'll be visiting our knowledge check tomorrow, and tomorrow it's going to be an open class whereby we will be treating the knowledge check, and all of us will be taking note of the knowledge check. In case there's any question, we'll sit down together and answer that question. There's no question that is outside the scope of this book, so we'll sit down together, answer the knowledge check, we keep it in mind, so when we move forward and we discover where we are going to go. So that is fine. So I think tomorrow we just talk about the final section of session 4. We do a bit of our practical tomorrow. Then we still have 2 more sessions to go. We still have 2 more sessions to go. We still have 2 more sessions to go. Session 4 and 5 tomorrow, and we are going to walk through. We're going to walk through our questions and go through these guys, our practical. So that's that. And finally, before we call it a day, so as I've been saying, that exam tips, yes, like the question Titi asked, Um, there's no question. There's no exam question. But let me share my experience. Um, one thing I did was I try as much as possible to cover 80% of the book. Take notes. Like when I'm reading, I take notes, and at least I had two reading. So what I mean by two reading is I read book one twice, I read book two twice. So it's possible I might not have that luxury time. That I was also working, so I was fully working and fully working, fully engaged. But at least I was still able to create some time to um read. So I just feel like, okay, let me pick one day per topic, and I keep pushing it that way. Just imagine if you just pick one day per topic, and that is in 1 hour you might finish one topic, and before you know, you've completed a book. So when reading, take notes, do exam checks, solve questions, and you'll be good to go. So but the shock of my life was that anytime I attempt the online exam, like say the test question, I discovered I don't perform well during my test question. I don't do fine, and like wow. So I feel like will I pass this exam, sha? So but I keep believing in myself. And another second wave of shock was that a day to my exam, there was a 20 question to prove if I'm ready for the exam. So and the 20 question came a day to the exam, and I did the question. After doing the question, the response I got was, Edward, we are sorry, you are not ready for this exam. Please go and prepare again. And I've already scheduled the exam. So I felt very bad, and I felt like, wow, after what I've read, these guys just want to kill me. And I need to call one of my senior colleagues, and I told her, they told me I'm not ready. They said, Edward, just go and do it. So, and well, I picked up my courage and went to the exam hall. And one thing I did was I also tried to relax myself, because one thing is tension blocks memory. So I make sure, yes, you already told me I am not ready, but I need to relax myself. I don't need to be full of tension. The highest thing that could happen is pay extra $50. So I went to the exam hall with a fresh mind, just do brief revision of my notebook, and I went to the exam hall. And the good story was that after the exam, I passed. So when I even checked my performance compared to the global standard, what is the average performance in the globe? I discovered that I performed far above the global standard, like the global average. So the question is this: what do I need to pass? All you need to do is that read your material as much as you can, answer all questions. You might do some test questions and they tell you, okay, you've not passed 60%. Don't get discouraged with those questions. Go and face the exam with open mind. We had a lot of guys did DASCA. We had a lot of certified guys in Octave. A lot of certified guys. So and there's no big deal to it. It might feel discouraging. I feel like maybe I've not done enough. No, their question, like what I keep in mind to the exam was that their question will be commonsensical. So what I only do is that I make sure I read. I do tell my guys, if you read the material, there's no way you won't pass. That guy is not like Nigerian exam, and they will go out of syllabus. So it's simple. We can start preparing now, reading each question, trying to solve each test question, and at the end of the day, we discover that we are going to ace the exam. So thank you very much for your time. We meet tomorrow for 12 o'clock. And it's also going to be an interesting time for us tomorrow also. So thank you very much. So any question before we call it a day? Hello? Okay.
No question from me. Thank you so
All
much.
right. All right. Thank you very much. Thank you for your time. So tomorrow we are going to review session 4 and 5. We are going to do as much as we can. We are going to please and please let us all attempt all knowledge check. So I will not be the one to answer the knowledge check. Each of us we are going to pick a chapter. We will be answering the knowledge check, and we'll see that it is simple, and we'll see that we are already ready for the exam. It's not that this thing is simple. So if we can do it that way, whereby we all attempted all the knowledge check questions, I can tell us that we are ready for the exam. So that's the method that I feel can help us. So we'll be working through section 4 and 5 tomorrow and all the knowledge check, and we know we dusted module 1. So thank you everyone. Please do have a splendid night rest. Good night.